Hello, I'm Scott, and today I wanted to share a quick practical print I put together to repair one of my Monkey Minions violin case. It had a broken retainer for the bow, and they asked if I could fix it. At first glance, it looked like an easy 3D printing fix, but then I realized it was a little trickier than I first thought. So I thought I'd go ahead and share how I was able to do this simple printing repair with Tinkercad. Yes, I know some of you just snickered and scoffed and maybe even quit watching because I mentioned Tinkercad. Tinkercad isn't as powerful as Fusion, Onshape, Inventor, or whatever your favorite CAD software of choice is. But sometimes you just need a small hammer for the job, and not the entire tool department from Home Depot. So here's the broken part. It attaches to the case with two screws and has a piece that swivels on top that's under spring tension to hold the bow in the case. My quick assessment first made me think that I could just create a new top arm, but then I realized the screw appeared to be integrated in the injection molding process. And then I realized that the nut on the back of the screw was permanently fixed with a glue or something. It wasn't coming loose. So after a moment of pondering, I raided my stash of stuff and retrieved an old spring from a ballpoint pen. Cutting it in half would probably work, and an M3 screw would fit nicely in the spring. So the next thing to do was to take some measurements. And then I headed into Tinkercad. First thing I did was establish the holes to mount it back on the violin case. Those were 3mm in diameter and 42mm apart. And then the base section was about 10mm in diameter. So I'm going to switch to orthographic so I can look straight down on this. I'm going to lock these two in by grouping them, and then I can select the whole thing and align it. And then I'm going to slide in here, grab this, line it up onto one of these lines, so it's just real easy for me to work from. And that puts the other one right on a line there, because all my numbers are going to be in pretty large increments. And we're going to make this 5mm high. Bring these up so we can see them through. And now I'm going to ungroup these briefly, duplicate them, oops, and hold down the Alt key and the Shift key to bring those up proportionally, change them to 10, do the same thing over here. Duplicate, which I could have hit D on my keyboard, 10, and then these are going to come down to be 5 as well. Get that out of my way. Oops. And we're going to make them solid. And just to make this look a little prettier, I'm going to run the sides up to 64 on these just so they're a little bit smoother. Really won't matter, hardly be able to tell at all once these things are printed and they're only 10mm in diameter. Now when we look at that, I measured 50 for my total length and I'm getting 52 now. It really doesn't matter as long as these holes are in the right spot. Now we'll do this section in the center. I measured about 12.5 overall. I'm just going to make it 13, and then it needs to be 10 as well. And we want all of that lined up on that axis. I'm kind of done messing with the bottom for now, so I'm going to go ahead and group it by grabbing everything, shift click on the center, and then group, and then that just locks that all into one piece there. And heck, I'll go ahead and change it to a different color so it's easier for me to work with and see what's going on. Now the centerpiece here, like I said, I'm going to have it be 13. It sticks up 8 from there. I'm going to center it on there, and when I grab both of those, I see that's grayed out, so that means it's already centered. Cool. A little bit of quick math tells me that this is 10mm across, so I want my raised area here to be 10 by 10, and it's 8mm from this top edge to here, so that means if I put a curving radius through here, that's going to be an 8mm radius, 10 and 8 more. So that means this red area here needs to be 26 millimeters wide. So I can grab my handle, hold down the Alt key, and this will scale proportionately to the side to 26 millimeters. This next part here, where we put our curves in here, these radiuses, that's where people start to complain and get grumpy about Tinkercad. People who think more visually and spatially can get their heads around this a little bit quicker. So what we're going to do is we're going to roll this over a little bit. We're going to come over here, we're going to grab a negative cylinder. I'm going to spin it onto its side, and I'm going to make it 16 millimeters. Then this is 5. So we hit down D on the keyboard, drops the selected item, this cylinder, all the way down the bottom. So then I know I can grab this and I can raise this up 5, change my sides, click front here to slide it all the way over and come over, and boom, now we've got this arc here. I can hit duplicate, bring it over 26 millimeters. We select these and group. We now get that swooped out cut on each side. So now the final thing I need to do to get my basic shape done here is to put my, hold down the center, which is not 30, it is 3, and it's going to be in here. And again, we can do our trick. Now I'm going to show you another trick here with centering. So I grab all of these and I hit center, and we can see our handles here. But if I click here, notice it's going to shift the base as well. So what I can do now is click on the base and see now my handles line up on the base. So when I click the center here, this hole moves and the base does not. So that allows me to keep my base in place rather than having it constantly jumping around while I'm centering things. So now I'm going to grab all of that and group it together, and that completes my base shape. We're going to have to do some more detail on this, but I'm going to move over to the top piece that goes on top of this. So it was 10 millimeters wide as well, and it was roughly 42 millimeters in total diameter. And because it has the 10 millimeter length here, or width, that means if I put a circle on the end here, a curve, it's going to be 10, so that's going to be 5 millimeters radius here and 5 there. So if I take those off, that means this needs to be 32. Now when I measured the top piece with the calipers, it was only about 3 millimeters thick. And I'm not going to get fancy by trying to encapsulate that head into the part the way they did with the injection molding. I'm just going to put a hole through it, and to give it a little bit of extra strength, I'm going to make this 6 millimeters high. Now I just need to drag some curves out onto the end of this thing, and I could use these circles or cylinders and overlap them, or I could get fancy and I could bring out the semi-cylinder. Now I got to reposition it a little bit differently because it doesn't come into the same orientation where the cylinder came in automatically, but we'll do this just for the fun of it. It's now protruding underneath the plane. I hit D, I bring it up. I'm going to go ahead and bring this down to my 10 first. I want to grab that corner so it scales. If I grab here, it's going to squish it. So I'm going to make that 10. Then we said this was 6, right? So now this needs to be 6. And we're going to have it here. And because I'm working in increments of a 0.5 millimeter, I can just do this. Oops. There we go. Go back up. There we go. So they're touching. There are ways you could get more precise, line shapes up, but for what we're doing with these increments, piece of cake. Now I could duplicate that, drag it down, and spin it. And now the whole thing is 42 millimeters. Now I'm just going to group it real quick. You know, actually, no. I need a marker. So I could ungroup it, but also I can just go here to solid and click multicolor, and it's going to leave this one piece again, but it's going to let me see those colors I had before, and I can use those colors to line up the holes that I now have to drill. Or no, I don't have to put holes in. I'm just putting a hole in the center. So that's going to be a 3 millimeter hole. We're going to center, so I select both of them, hit the line tool, click the base there, hit that, hit this, and that now puts that perfectly aligned in the center there. The original top had a bit of a curve on the top face. Now first off, this isn't going to be the top. This is going to be the top because we have to have these indentions cut in the top over here. So that means what we can't see here that broke off was raised sections that lock down into there to lock that top piece in from spinning. So that means I need raised areas right here. Well, if I just have these little raised areas up on top, let's go ahead and put those in first, I guess. So I measured the originals, and they're about 1 millimeter high, and they were roughly about 2 millimeters wide. And I know this is 10, so it's going to be 10. And I hit tab to go back over here so I can hit this as a 2. I could do my little trick where I count up here, but I'm going to show you another little trick here. So I can grab this base plane or work plane tool up here, which is W, drag it onto this surface here, and now that becomes my work plane, my base. So if I click this and I hit D and drops it to the plane, well, the plane now just happens to be raised. So that way now I can make sure this is sitting right on top of that. Click back on here, click out in the middle of nowhere, my plane goes back to where it was originally. I need a little raised cross on here, so I'm going to duplicate that, and I'm going to spin it, get my little handle there, 90 degrees. And I will go ahead and group the two of those, and we will align them with our base. So now we see that this area right here is raised, so it can't be the bottom because I'd have to put support all in through here. And I could get fancy by bringing in like one of these cylinders to make a curve, make it a negative and cut it out of a positive, and use that as a tool to cut through to put a curve down through here. But printers don't print bottoms of curves very well like that because you've got such an extreme overhang. So all I'm going to do right here is just bring in a wedge. This is 10 across. So I know that for my printer with the PEI surface, I can get quite a bit to stick to it. So I'm going to have at least 3 millimeters wide by the 42 across of contact area here. So that means I can take my 10 minus a 3 gives me 7, divide it by 2 gives me 3.5. This long. Use my keyboard just to back that off because I'm using those half mil increments. I can just do that real quickly and it's going to line up right on there. Duplicate again, bring over, spin it 180 degrees. And if I click the left up here, it can give me a straight down left view. Boom. Now select both of these, hit whole, and now select that and group. Now we've cut a chamfer down the sides of that at 45 degrees, but to me 45 is a bit too much for that. So I'm going to go back, I'm going to grab those, and I'm going to bring those down to about 2. And here's another little trick we can do. I can double click on this and it will ungroup one step back. So, and then you click off of it to get rid of it. So I double click on there and now select my base and my cross and group them. And then when I click off, I'll see that my hole now protrudes through the top, so I can grab those, group, and boom, now I got the hole all the way through. I need to replicate this pattern up here, but as a negative, so these will lock into it. So I'm going to just bring out another negative. Now I made these 2, and I want this to have a little bit of clearance in there. So these are going to be 2.5 by 10, and they are going to be 1 millimeter high as well. So I can select that, and it's a Control D for duplicate. I may have said D earlier. If I did, I'm sorry. Group those and bring that kind of up, select both of those, do my trick where I select that, align it there, and I can grab my base, drop it there, hit down, and now all I have to do is sink that 1 millimeter in. Group that, and now I've got these two pieces, have holes down the center of them, have their interlocking pieces that will go down there, and we've got screw holes to put the thing down into the ground, or into the case. At first glance, we might think we're done, but we're not, because the screws that we're using have heads. So I need to put in some clearance for the heads of these screws. So when I measured the heads of the screws that attach to the case, they need about 5 millimeters of clearance for the head to sit down inside of here. Well, I'm going to bring this over. Now there's some fancier tools we could do for drawing out rulers and things in here, but I'm not going to get into that right now because we're doing a real quickie here. Here's another down and dirty trick I do in Tinkercad sometimes, which are probably going to make some Fusion guys and other CAD guys go insane. When I line this up and get this cross here, like right here from this grid right in the center there, I can real easy take my other piece that I want to line up on there and line up on there, but it won't fit, right? Because I'm going 1/2 millimeter. I need to change this to 1/4 millimeter, and boom, it'll line up. I could have typed it in, I could have done a lot of different things, but this is a quick and dirty thing that I'm just trying to knock out as fast as I can. Now, right now, that hole's going all the way through, and that's not going to work. We said originally that this piece here was 5 millimeters thick, so that means that my hole's 5 millimeters thick because it's touching on the bottom and flush. So if I just grab this and drag it up 2.5 millimeters, that means that I have a smaller hole going halfway through, and then it becomes a larger hole for the screw head the other half of the way through. So I can click that, I can duplicate it, I could have hit Control D, I can click this, drag, hold down the Shift key, move it over. These were 42 millimeters on center, and boom, there they'll work. Now, if I want to see what's actually going on, I can take those, I can group them, and I can hit T, which is the same thing as clicking this transparent box, and I can look at it from the side, and I can see, yay, look at that. I've got recesses there. Now, I have one other problem. I've got a screw that's going to come up through the bottom of here. The screw head is going to sit up here, so we need to do a similar thing right here to make access for it, but it's going to go down and through here, and I have a nut and that spring that need to fit inside of this column right here. So I measured the nut that's going to go in there and the spring, and I determined that 6 millimeters is about the right size to go inside of there. So we'll get us a 6 millimeter cylinder, negative cylinder, and again we will align it to the center of this, and we're going to need a lot more room. How do I get a hold of that in there? So if I click here, I'm going to grab the outside of it. I could try to click the bottom. I got it, I got lucky, but I might not. Another thing I could do is click and drag to grab both of them, and I see I have 2 shapes selected. Hold down the Shift key, click my big shape, and now I have my little shape selected. Now we said this was 13 to the top. Yeah. And I'm thinking we're losing a millimeter there, and probably 10 millimeters is probably good. That gives me 2 millimeters right here to clamp onto, and I'm thinking that's going to be plenty to make sure this doesn't pop off. So now if I grab those, group them, now I've got a recess in the center of that thing for my nut and my spring to go into and my screw to come in from the top. So the only thing left to do now is to put a recess over here. And when I measured the head of that screw, I determined I needed 6 millimeters for it. So I'm going to do a real quick little trick here. I'm going to double click on here. I can click there, grab both of those, click here. Now I've got that there. That center piece that we just drew, the 6, I click duplicate, and now I can hit Control X to cut it, select out, let that group go back together, Control V, and it's back down. And now I've got that same cylinder there. So now I can take it and select here, so I can align it to here and to here. And I need this to be about the same 2 millimeters worth of clearance for that head of that screw to sit down inside of there. So I'm going to make this 2 millimeters. It's sitting on the bottom. Select it and a group. I can click it, I can click T, and I can see that it now has a recess for that head. Because of Movie Magic and the fact that I already printed this and installed the final fix, and then realized it'd be a cool thing to share, I now have this printed. And you can see the impression on my build sheet, the ghost from the one that I printed previously. This is a second one that I printed so I could show you it printed, because I already had the fix installed on the violin case and knew it was going to work before I decided to make this video. It's now been on there for about 3 weeks, and the report I get is it is working fantastic. But just to be clear, and in case anybody really wants to see it, here is an exploded view of how it's going to go together. M3x16 screw, my top piece, the little extended pieces here that lock into the little cuts we made here, goes through, the screw goes into the cavity here, and the nut goes on the end. I hope you found this video informative, and maybe you learned something. Tinkercad may not be the most powerful tool in our toolbox, but it can be a great tool for quick fixes, or a stepping stone to help you on your journey from benchies to functional parts. Functional prints like this are my favorite way to use 3D printing. There's huge satisfaction in being able to fix something rather than just throw it away. The 2022 IC3D Toys for Tots campaign is just about ready to kick off any day. And I'm already dialing in some of my prints and hope to be sharing some of those tricks in Prusa Slicer with you soon. If you haven't subscribed yet, and the odds are you haven't, please consider going ahead and doing that. Thanks for watching.